So what we're doing here is a preserving rotate. Normally, if you just rotated bits, you'd lose them. What we're doing here is we're doing this first shift. This is moves the most bits left. And then this value and 32u minus count over here takes the bits that would have fallen off the left side and moves them to the right side so that this ends up wrapping around instead of just losing those bytes. All right, so now it's time to start on our quarter round function. So this will be a void type of function. This will be our quarter round. Perfect. Now, what we want to pass in is going to be the state A, B, C, and D. So it'll be a 16. We'll remember, so these are 32 bits. There'll be 16 elements to the state. And then we are just going to need unsigned A, B, C, D. And let's look back at exactly what we're doing first. So A modulus addition for A equals A plus B. So state A is, then we take state D, XOR with state A. Then we take state D and rotate it left by 16. So we're going to take our state D, rotate left 32, state D by 16. Okay. Next, we are going to handle the second one, that is right here. So C equals C plus D. Now we're ready for the third one. And I'm sure you can see from the pattern here, but this was ADD, this was CBB, this is going to be ADD, and then the fourth round is going to be working on CBB again. So for state A, we're doing modulus addition to state D, B, B. Then we are XORing with state A. Then we are rotating left state D by 8 bits. State D, looked the wrong one. State D by 8 bits. And then finally for our fourth, we're going to do modulus addition between state C and state D. Our XOR. And then our rotate left by 7. So this is our quarter round function. And you can see that this follows quite in step with what we pulled out of the paper. Now that we have our quarter rounds done, we want to go into the full rounds. So this will be a static void function. We'll just call this our cha-cha 20 rounds. These will be 32-bit again. And we will just be passing in our state, 16 total elements of our state. And the round will be an unsigned number. So we'll start our counter at 0. while round is less than 10 because we're doing 10 rounds. We'll increment the rounds by 1. And now we're just going to call our quarter round process passing in the state that we get when we pass this into the Cha-Cha 20 rounds. So it is our XCP Cha-Cha 20 quarter round. I don't want to type that 10 times. And we're going to pass in the state. And then this is where we get that order from. So this is where we need this order. So let's state, actually I'll just copy this. First one is going to be 0, 4, 8, 12. Next one is going to be 1, 5, 9, 13. Next one is going to be 2, 6, 10, 14. Next one is going to be 3, 7, 11, 15. Next one is going to be 0, 5, 10, 15. 1, 6, 11, 12. 2, 7, 8, 13. And 3, 4, 9, and 14. All right, so this is our Cha-Cha 20 rounds full function. Need a full look at the code there. This is so we now have our constants. We're importing string.h because we need memcopy. We will need memcopy. We have our load and store functions for word manipulation, our rotate left function, our quarter round function, which uses that rotate left function, and then our Cha-Cha 20 rounds, which just instruments that Cha-Cha 20 quarter round function.